Well, welcome everyone to the Interstate Batteries Pro Clinic webinar on troubleshooting electrical systems. We'll begin in just a minute as we wait for a few more folks to join us. In the meantime, a couple housekeeping things. If you would, go to your Zoom toolbar. You should see a rectangular bar either at the top or bottom of your screen. And inside there, if you scroll over, you'll see a Q&A button. Go ahead and open that up. That's your lifeline to us. If you want to ask a question at any time during the webinar, you can do that there. We're not going to be looking at the chat, so you're welcome to use it, but we won't see it. If you have questions, though, we encourage you to ask them during the webinar. We'll answer what we can while our hosts are speaking. If there's something that we can't answer or something that everybody needs to hear, we may save it till the end, but those questions help us make better content for our next webinar, so please put that in there. Just a reminder, this webinar will be recorded. You can listen, you'll get if you have to leave early or something, you should receive a link at the same email that you used to register with. You can also share this with other people in your shop, and we encourage lots of people to attend. And Lou says Delaware sees and hears us loud and clear. Good, Lou.
Yeah.
Lou Spinelli. Oh, dang it, I'm not supposed to say the last name. Keep forgetting that.
Stop that.
Well, let's go ahead and get started here, unless I forgot something. We're talking about troubleshooting electrical systems, fundamentals. And with us, we have Gail Kimbrough, who put mental in fundamentals, and Jeff, who puts the fun in fundamentals. And we're going to talk voltage and ground, voltage drops, resistance, corrosion, all sorts of fun stuff. And at the end, we're going to have a one-question pop quiz. And we'll take, like I said, take your questions throughout, and we'll have a Q&A at the end of the session. So with that, let me more properly introduce our hosts, Gail and Jeff.
Hello, hello. Welcome aboard.
Hello.
Hi. They have almost 100 years of experience in the automotive industry, and either cars, car parts, batteries especially. They help design our battery testing lab, where we test the quality of every battery manufacturer that we carry. They both received multiple certifications during their careers, and Jeff and Gail have written and published articles for trucking magazines and Automotive World, and they both have a passion for helping others learn and having a good time while they're doing it. So guys, thank you again for joining us.
Hey, thank you.
Our pleasure. We
Also,
appreciate everybody being there.
Also represented in this particular episode of Pro Clinics is Gail's close personal friend, George Ohm.
Oh yeah, I think he and I graduated a couple of years apart from college.
Fortunately, we were able to get a photo of you and not just a painting. Well, too bad George didn't make it a little bit longer. But yeah. Cool. So like we said, George will pop up later in the presentation. We'll kick back to him. But first, we're going to start talking about just like principles of troubleshooting in general. And as mechanics, you're part detectives. So Jeff, why don't you break that down for us?
Oh, you got it. So we're going to break down kind of the aspects and the process of, looking at the different things when you raise the hood right off the bat. So when you raise up the hood, you want to see exactly, anything that's obvious. Are all the belts there, broken hose, any broken wires, anything that's very obvious that you can actually see to start your journey with. We want to make sure that we're going to be fixing this correct the first time. So, try to get as much information as you can from the customer while they're there. Where was the last time it was worked on? How long has the problem been going on? Did it come from a body shop? Not that we've ever, encountered that before. Hopefully you don't have one that comes in that looks like this picture up on the top right. If you see one like this, my suggestion would be close the hood, tell them to have a nice day, because I have a feeling if they've got it engineered like this, you're probably going to encounter a whole lot of more problems than what you've actually wanted to deal with. So,
I think I could even spot that.
Yes.
That's a good visual inspection.
Mm-hmm.
I think there could be a little issue there on cranking. What do you think?
Yeah, just a little bit.
So yeah, do the best to get all the pertinent information as you can right off the bat. You know, it's really bad if you start working on a vehicle and you kind of run into things and you have to go back to the consumer again and say, hey, look, kind of run across this. Is there anything else we need to know? So anything that you can get out of them in the beginning really helps you out when you're looking for the issues. So we'll just want to make sure that we're fixing it right the first time when we are working on this thing. Look for your trouble codes. That's going to get you going in a direction. Now, keep in mind, there's just codes, and of course, those codes can actually come across for a lot of different circuits on it. So it'll get you in a direction, but it's not always going to put you in the point of what failure is going on. A P303 code is not going to be able to tell you, you know, is it the injector? Is it the plug? Is it the wire? Could it be a wiring harness? So look at your hard faults, you know, the codes that actually will not stay away. I mean, you clear them out, they come back. Soft codes, look for those. I mean, small things can actually create a huge nightmare for us. And we want to be known as the mechanic that fixes everything that is thrown at them, not a parts replacer.
Yeah.
That's not what we want to be called.
Don't forget the principle of starting with the simplest explanation. I spent the better part of a weekend trying to figure out what was wrong with my oven and stove and why the gas wasn't coming on. And I was about to replace some pipe behind there, and I went to go turn off the gas, and I saw there was a padlock on my gas meter. We had forgot to pay the gas bill. So start with the simplest explanation.
That's a very good one, Kyle. Hold on.
Yeah,
I'll give you the bell.
Thank you.
Hey, that top one, Jeff, reminds me of the guys that get somewhere and they end up with a nail or a screw that they're pounding into between the post and between the terminal and the battery, try to make good connection.
Yeah. Or, you know, screw that screw in there really good too.
Oh, nice.
Absolutely.
Well, Gail, take us through voltage drops.
Yes, we're going to start talking about voltage drops. One of the things that brings us to this is we can go through fault codes as Jeff was talking about, and we go through all the different things. We live in a computerized world, but let's never forget the simplistic as we were talking about just a moment ago, and also the troubleshooting that brought us here. And so voltage drops is one of those situations. Today, we're going to be talking about voltage drops. The energy is lost when current passes through a resistance. When that energy of intensity or current passes through a resistance, it allows a voltage loss that will a lot of times or can hurt or damage your whole electrical system and or not allow it to work properly. That's very important. Normal voltage drops occur oftentimes, but we're going to give you the goods and the bads of voltage drops so we can understand when we need them and what they are. One of the things about that brings to mind is this freeway on the right side. When we've all been on freeways where there was 3, 4, 5 lanes and it got brought down to 1 or 2. What happens in that situation is, number one, you have a lot of people trying to jam themselves into 1 or 2 lanes. And because of that one car that's trying to get the very, very front in front of everybody, there's going to be friction between drivers. Well, there's going to be friction and loss of voltage in what we're going to talk about today. So it's going to cause a lot of situations. Unwanted voltage drops are something, again, we've got to talk about and show the fundamentals of, etc. And so start broad. One of the things that I want to bring out today is when we talk about batteries and electrical systems, etc., some of the fundamentals also that we need to take care of before we get to voltage drops is making sure your battery is good or bad, because obviously it can start to give you problems that can be a culprit before you ever get to voltage drops. But let's say that you've checked the battery, you've looked under the hood, you've already done a great visual inspection, and you found possible things wrong, but corrosion connection, etc., visually. But at the same time, we're going to talk about the SAE, or Society for Automotive Engineers, recommended voltage drops. For example, on small current computer connections, low current accessories, instead of 1 to 20 amps, as an example, the voltage drop maximum is 1/10 to 900ths. And so going higher with the current, as we get to an alternator, high current accessories, etc., like some of the headlights, some of the blower speeds, etc., on fan motors, 20 to 100 amps, that's 1/10 to 2/10 of a volt. And then 2/10 of a volt are battery starter cables. That's a higher current, obviously during cranking. And then the maximum 2 to 3/10 of volt for heavy duty switches and solenoids. These are very important to remember and jot down and or have there on your toolbox to remind you, because at some point you're gonna need to refresh your memory on what those are. So take a pictorial of it, make a picture, put it on your toolbox so that when you open it up, you'll see the recommended voltage drops for doing troubleshooting and voltage drop measurements. So in the next one, we're going to look, on the next slide, we're going to look at also voltage drops and look to see utilizing that formula of voltage, current, and resistance, something that we have to deal with on a consistent basis on the electrical electronic system every single day. And that's taking your multimeter and testing current and or resistance and or voltage. But always remember that I, intensity or current, times resistance always, and it's a law, always equals voltage, which is demonstrated here by electromotive force, which was, so if we were to put this into our terms, sometimes we would say C for current times resistance equals V for voltage. But regardless, it's I times R equals Z, or current times resistance always equals voltage. And we're talking about voltage losses here. So if we put this into perspective, if I had 1 amp of current flowing through a small wire and I could achieve a zero resistance level, which I cannot actually achieve, but if I were to have that capability, I would have a 0 voltage drop. Even if I applied 100 amps in this case and could achieve 0 ohms or 0 resistance in a component or cable or whatever, I would have 0 loss. That means whatever I had at the battery voltage wise, I would have available to all the other components in this circuit. Putting it into a more realistic terminology and understanding, I times R still equals Z, but let's put it in realistic terms. And 1 amp of current times 1 ohm of resistance would equal 1 volt drop. Putting it into a starting type scenario or high amp scenario, we have 200 amps times 100th of an ohm. That's minuscule with regard to the amount of resistance, right? So, but if we have 200 amps flowing through a cable or connection and we have 100th of an ohm, remember, we just lost 2 volts drop. We just lost 2 volts on our circuitry. And so if we have a battery that's at 12 volts and we have 100th of an ohm and we start that vehicle and we have 200 amps going through that cable, we go from 12 volts at the battery to 10 volts at that starter solenoid, as an example. And if we have 200 amps times 200ths of an ohm, we obviously reduce it to 4 volts drop, or from 12 to 8 volts at the solenoid. And that's when you start to get some of that clicking and some of that grunting from the starter motor, et cetera, when you start losing that much. But anyway, so small amount of resistances can lead to humongously large or increasingly large voltage drops in this situation. So it's important to remember.
Where our friend George Ohm comes into play, and he was probably the life of every party.
Yeah.
Oh yeah. Yeah. He walked in and said, "Hey, I times R equals E," and everybody cheer.
Yeah.
He's ready to charge you up.
Yes, he was.
Well, y'all make sure you send us more questions. We had one person that wanted to clarify, when you say recommended voltage drops, sounds like you need them. That's a minimum, when it's actually meant to say that these are the maximum allowed, correct?
Yes, that is
exactly.
correct. These
Yeah.
are the maximum voltage drops by the Society of Automotive Engineers, which set the standard for a lot of different things, cables, connections. They set the standards for the size wire that you need on your vehicles. They set all kinds of standards. They have a huge book that outlines multiple things for your vehicle.
You mean
Okay.
books, plural.
Books and books and books.
Jeff, why don't you talk to us about the causes of voltage drops?
Oh, you got it. So as we click in here, let's talk about some excessive current draws, which are normal going to a starter because it's going to have a lot of current to be able to spin an engine over. Now, there are things that can create a high resistance factor that go beyond what we would actually expect or need. So having a partially shorted starter windings or even internal engine problems, oil viscosities. So you got to remember, as the temperatures get colder, like we had Snowmageddon here in Dallas, the temperatures get really cold, and cars and trucks are like me. They don't like to work in the cold. So when that oil viscosity gets thick, it's going to take a lot more current to actually spin that starter and flywheel over to get it to crank. So that's why there are set regulations, or I say regulations, there are OE specifications for CCA values for a vehicle, and that's what they're there for. So if you're replacing a battery, make sure that you're following the OE specifications for your vehicle and don't go below what it's showing. Now, our clamp-on inductive amp meter that we've got on here, we can actually see what kind of alternator output we've got going on when the vehicle's running. We've also got a video showing how we do testing amperage going to a starter, just to see exactly how much it's going to take to start a vehicle. So I think you could run this or roll this little beautiful beam footage here.
So what we're going to do now is actually look at the amperage draw once we crank the vehicle up to see exactly how much amperage it takes for this car to spin over to actually get it to start. Ray, you want to go ahead and turn it over? What was that, 254? And right now, with the loads that Ray's got on, the alternator's only having to push out about 9 amps. Ray, turn on some of your loads. Turn your AC on high. So you saw that actually ramped up there really high. What's going to happen is the alternator is actually going to ramp up on the voltage side as well to offset and keep the amperage a little bit lower. So it's kind of stabilized now. So we're looking at 2.0, 2.5, somewhere in that neighborhood that we're actually bouncing around just on the load demand.
So you always want to do that with the engine running?
Yes. If you're looking, especially if you're looking to see what kind of amp draw it takes whenever you're cranking, or if you just want to see what the alternator's outputting. There's a lot of diagnostic tools that allow you to do this. Clamp-on inductive amp meter for us is kind of quick and easy. You just put it on the dial you're looking for as far as amperage, and let it run.
Mm-hmm. And you can put this on
either side. Yes, it doesn't matter. You can get a negative reading. It's still going to give you a reading.
It's the current's either coming or going.
Exactly.
Gotcha.
Still flowing.
Gotcha. Okay. Well, let's talk a little bit more about causes of voltage drops. Gail?
Yes. Some of the causes of voltage drops, Jeff talked about the engine and about oil viscosity and some of those things, and the battery having only 40% at 0 degrees Fahrenheit or minus 17.8 degrees Celsius. And that's very true. So putting it in a bind, so to speak, but normal current, we're going to talk about normal current, but reduced capacity or capability. You see on the right side of your this PowerPoint presentation, an exploded view. In the battery industry, we don't like to use the word exploded, but we're going to use it with regard to this wire or cable today. But anyway, you see that this is very much like that freeway where they had a lot of lanes of traffic and current could flow through all those individual strands of wire, but then it got cut down to all but 1 or 2. And now all of that current that was flowing through there has got to flow through 1 or 2. That's going to cause heat. It's going to cause problems. It's going to cause a voltage drop. And that's what we're talking about today, is some type of resistance factor that's reducing the amount of, or trying to go against that current flow in a circuit and causing a voltage drop that's measurable. And that's whether it's on the positive side or on the negative side, as it illustrates on the bottom pictorial. It's illustrating the metal frame and that resistance factor between the metal frame and the connector. And so we're going to talk about corrosion, which is a normal situation in and around the battery because of various things, cables, connections, exposure to a wire that's not covered. For example, you're going to see a lot of corrosion on that. It's a normal result of electrolysis. And you also see situations caused by chemical corrosion, salt and moisture, the moisture in the air, being around the Gulf of Mexico, or being around various things that have a lot of high humidity and those types of things. And that's normal for there to be corrosion and connection problems. So we're going to talk about that as we go through here more and more in depth. So y'all stay tuned for what we're going to be talking about as we go forward to the next slide. As an example, this voltage drop on the pictorial on the right, you can't see it, but on this, what we're trying to show or illustrate is taking a multimeter and have this cable that's loose from the between the this starting cable that's disconnected, and we're holding it in our hand and we're checking continuity. And continuity is great. You can put it on resistance on that multimeter and check to see if this wire that's green with a yellow stripe is the same wire you're seeing up under the dash. That's a great thing to use. But in what we're talking about today, resistance, you can't check resistance by continuity checking in a large cable or connection, because it will not show the type of loss that you have. For example, this has all the strands broken, but it will still continue to show a great continuity factor because it has one strand that will carry the current from that meter. So it's a situation of can't use this type of situation. So you have to, or need to, be prepared to use a voltage drop measurement, which is tried and true. And so take your digital multimeter voltmeter and put it on the DC setting between 2 and 20, or if it's automatically adjust, that's fine. But we're going to be testing cables and wires and testing the metal, not the coating. And when it says use no woodpecker tracks, that's going into the wire. You know, when we take the end of the cable, the digital multimeter cable end, and we touch it and we penetrate but in the cable, outside cable, to touch the wire. We've all done that at some point in time, especially up under the dash, and we're looking upside down at some of the wires and trying to figure it out. We have penetrated that. That's not a good thing. When you do that, Jeff's going to reiterate to me in just a moment, reiterate to you about what you should do there. But when you do puncture that, obviously you should seal it with something. Testing a damaged cable also alone by itself shows no drop if you have it outside the circuit. So you need to put it, pardon me, you need to put it in the circuit, leave it in the circuit, and use the dynamic way of testing. When I use the term dynamic testing, I'm talking about use it in the way that it's used. For example, we've got it connected to a battery, and we've got it connected to the starter solenoid within that vehicle. And so it's connected in the vehicle. And now we're going to take our digital multimeter and we're going to connect it between the positive post. Remember the positive post there, and then to that starter solenoid connection stud. And then what are we going to do? We're going to place current through it. How do you do that? You start the vehicle. During cranking, you know that there's current flowing through that red cable going to that, if it's functioning at all. And you know that there's current going through that. We know there's resistance because we see the broken strands. You won't be able to see it, but we will see it in this pictorial. And then also, if there's current, if there's resistance, what does that give us? It gives us a voltage drop. And in this case, it's 1.8 volts. What that means is that if we start with 12 volts at the battery, we get what? 10.2 at that starter solenoid connection. That starter solenoid connection is not going to function correctly if it's getting that low, typically without or in that load type situation. It's not going to clamp those connectors together like it should. And so making sure that we connect to these and check it dynamically is very, very important. We're also looking at a cable. Obviously, if you were there and did a visual inspection and saw this type of cable, you would know that it's open enough to where corrosion connection problems can exist within that cable without seeing it. But a lot of times you can't see the inside. And so in this cable, you would probably tell that customer, I need to replace this cable. It's been cut, and there's going to cause, if it's not causing problems right now, it will cause corrosion and connection problems in the future, in the near future. So you would say, I need to replace this cable or connection before it becomes worse. And so voltage drops, where and how to look for them. Testing voltage drops in cables, you need that voltmeter and digital multimeter, and you go place it on the DC volt scale and the 2 to 20 volt, depending on the meter. And then we test cables and wires, test the metal on the grounding side. And as we reiterate, leave no woodpecker tracks that allow corrosion. And testing a damaged cable alone does not show drop if you've got it outside the vehicle. Testing with the vehicle running and loads on always. Starting, lights, AC on, etc. in our testing that we're going to be conducting.
All right. And a fun fact we learned earlier is sometimes when you see that damaged cable or the covering on the cable, we didn't know this, but those can be soy-based, that coating, and that can be very attractive to the varmints. So that was something I learned today.
Yeah, we've had several cases where, especially in the change of the temperatures, where you have rodents or critters, whatever you want to call them, that are nesting. And if a vehicle stays parked for any length of time, that's a very good source for them to start nesting and start chewing on wires to, have feeding frenzies. So you got to love that.
All right. So you need to crank the engine in order to see the voltage drop.
Yeah, and you hope that the critters haven't got to it to where it won't crank.
There you go.
So expand your search on these other components here. So our illustration here with this picture is kind of outlining some of the corrosion on the wires. As you can see, it's exposed wires. And in a case like this, if you're trying to get high current through there, you're going to run into a situation at one point where it's not going to allow it. And you're going to be able to feel heat. If you're grabbing a hold of wires or anything, you'd be able to feel the heat off of it because, resistance creates, as we all know, heat. That's what can cause melted wires, melted post. So if you see things like this that are very obvious or blatant, please, replace those the correct way. And we're not talking about splicing. Gail, we talked about this earlier about butt connections and all that. That's not a correct fix. A lot of times, and especially with a lot of the newer vehicles now, if the wiring harnesses get damaged, you have to replace the whole thing. When you start splicing in, you leave these open connections to where moisture can get in and you start the corrosion process. And, 9 times out of 10, you're going to see that car coming back again. So look at screws, look at the eyelet connectors, check the wires and the post. Look for any kind of corrosion. And like I said earlier, on the heat side of it, look for signs of heat, and what that would kind of be a representation of is melted wires or corrosion that's gotten underneath the covers can actually start blistering them up. It looks like a little cancer that has started. So when you see things like that, you're normally going to be drawn to, this is corrosion, this needs to be replaced, and let's do it and do it right. So once you start figuring all that out, looking at your codes and all that, begin to look at all the circuits that you're dealing with as well, because you could have components that there may be 3 or 4 things that are on that one circuit that could be caused from a loose ground connection or a frayed ground connection. And, you know, Gail was showing you earlier about the broken wire. Well, if you've got frayed wires in there and you've got 5 or 6 different components on this one cable, not all these are going to function correctly, because as you start loading up that circuit, if there's not enough travel for the path of the current, then guess what? It's not going to happen. So you're going to have lights that could start dimming, multifunction switches that may not work correctly. So these are things we want to make sure that we're looking for, and once again, fix it right the first time. So that way you don't have the customer coming back in. And we all know how social media is. So if you've got one complaint, guess what? It's going to expand out pretty quick because of social media. So make sure we're fixing everything correctly, whether it's, you know, it's part of the wiring or whether you're just, you know, you got some components you need to replace. We want to make sure we're doing everything the way that we should be doing it.
All right. Want to talk to us about looking for voltage drops in parallel connections?
Yes. So as we're looking at voltage drops, now keep in mind this, when you're looking at parallel connections, you're talking typically in the commercial applications or RVs or whatever. So you can actually do this within these parallel connections as well and keep the engine running. And what you're going to be looking for is any kind of a drop that exceeds 0.3 of a volt. Because if that's happening, then you know that more than likely there's going to be a lot of either corrosion buildup, or you're going to have cables that are starting to deteriorate to the point where they need to be replaced. So we talk about this quite a bit, and Gail and I've dealt with it over the years, that you know, shops don't want to replace all the batteries, you know, if they've got only one that's bad. Well, I understand that, and especially with, you know, the times the way we are right now with the pricing and everything on batteries and, you know, just things in general. If you've got one battery that's bad out of a bank of 4 that you've got in this tractor trailer, and these other batteries are 3 years old, what you're going to do is take that new battery and you're going to drop it down to the same level as these other 3 batteries, because this new battery has to equalize with these others. These older batteries cannot equalize up to the new. So it's up to the new to equalize down to the old. So look for your voltage drops. We got a lot of new trucks out there that actually have what we call a bus bar that are connecting all 4 batteries together. Now, even though it's a brass bar or copper bar that's on there, these things can also still get corrosive buildup on them. And what that can do is create a starting situation where it doesn't want to do it because of that corrosion built up underneath there. So a lot of these you've got to disconnect and clean just to make sure that you've got good connecting surfaces on them, and you're not going to have a driver, you know, unfortunately get stranded alongside the road because his truck died or it won't crank. So look for your voltage drops. Typical, you know, as we're seeing here in these illustrations, you're looking at 1/10 of a volt. That's perfect. When you start getting up above that 0.3, then we got to figure out exactly what's going on. And of course, if you got 2 separate battery banks, then there's an issue you got to start to look at as well.
You know, Jeff, one of the things that happened to me recently was a friend of mine was running an elaborate sound system, and he had multiple batteries within that vehicle that he had in parallel, very much like you would have on a tractor trailer rig. So that's another area where you need to have, where there are multiple batteries trying to run accessories.
Oh, yeah. And if we've got any of those mechanics on here that are working on police cars or Tahoe police vehicles, you guys kind of know what we're up against when we're talking about auxiliary batteries as well. So we just want to make sure that, you know, we're doing the due diligence on testing and properly fixing a, you know, a vehicle.
Yes, they've got one under the hood, one battery under the hood, and one battery in the trunk.
Yep. All right, Gail, take it away. Let's see what's going on with this one.
Okay, we are illustrating a fundamental pictorial here of the battery, the alternator, the starter, the solenoid, the engine, etc. And we're utilizing this we're going to show the voltage drops on this because this is just a very simplistic electrical system, excluding a lot of other wires there, but it is fundamentally correct in that it's showing two primary or fundamental elements of a typical electrical system, that being voltage and grounds. And we all know that we've chased grounds for a long time on trying to find some electrical problems, and those phantom electrical problems or intermittent electrical problems. And Jeff, you were mentioning a while ago about one of those, we have that little corroded ground on going to the body, and it doesn't affect it until you turn everything on. And then once you turn everything on, it increased the amount of current going through those little wires, caused a problem. So troubleshooting the electrical system, we look for checking primarily, in this case, we're checking primary grounds. And so using that same pictorial, so we're showing that we're taking the digital multimeter, we're connecting it to the negative post of the battery. Remember, not outside the post, on the post, and we're going directly to a metal connection on the engine, a good metal connection on the engine. And what are we doing? We're cranking the engine so that we place current through the electrical starting system, solenoid, etc. And that's also one of the things to remember. If it's going through the positive, it's got to return, or it's going through the negative. And so the negative and positive current levels are the same when it's cranking. So in this situation, we've got current from the cranking. We've got obviously a resistance of some sort in any cable or connection. So we're getting 1/10 of a volt, and that's within specifications or within our maximum allowable limits. So we're also then going to the chassis ground, which all the accessories connect to, including the computer. And we're checking that from that post to that frame. And what are we doing? We're turning our key to the on position and turning on all the normal loads. You can even have this running and turn on AC, etc., because anything connected to that chassis ground, you want to run through that ground that it was illustrated earlier with the corrosion. So go go to the negative post and then go to the frame or the body of the vehicle and run things, allow current to flow through there, and you'll find if you have adequate voltage loss within that system. This is very, very ultra important, and it frequently are a cause of a problem that you overlook, or you start looking deeper into the electronics part of it and overlook the electrical system deficits, if you will. So that's very important. On the next slide, we're going to be going deeper into this same scenario. And I think that, Jeff, are you
I am
covering this?
I sure am. So here we're going from the positive post of the battery over to the B plus on the alternator. And what we want to do is kind of check for a voltage drop there. Now, as you see here, we've got kind of switches and solenoids and everything else in between. But we can actually look at this and idle the engine up anywhere from 1,000, 1,500 RPMs. It really doesn't matter. Turn your accessories on, and let's just check and see what kind of voltage drop we've got here. You know, one of my guys that works here in the lab, you know, he's been a mechanic for over 20 years, and he couldn't fathom how can you do this? It's not voltage. Well, it's voltage drops. This is what we're looking for, not voltage, but voltage drops, because you're going to have drops in cables, whether it's on the voltage side or the ground side. You are going to have voltage drops within these circuits all the time. So these are just kind of some of the principles that we're looking for to kind of point out to you guys. A lot of folks, you know, throughout their career in the automotive and commercial industry, you know, these are kind of the starting points of when you start learning things. So this kind of brings you back into a refresher course to help you realize, hey, these are some of the things that I used to do in the past and now I don't do them. And this could probably help me out as I'm moving forward on these newer vehicles as well. So our next slide that we're going to go through kind of goes through a little video that we did looking at some of the voltage drops and things that we were able to do here next to the lab.
All right, so we're going to start out and kind of walk through the process of checking for voltage drops in the cables now. Make sure you're doing this in the cables. So we're going to start out with just looking at battery voltage. So we'll put our probes across the battery itself, we're looking at 12.76 right now. And we do have a little bit of loads that it's actually kind of recovered from. So this is what we're doing here. Then we're going to go step over to checking out the cable itself. So Ray, if you want to go ahead and start it up. So we're way in good on these, because what we were looking for was looking for a 0.3 or below. So you can see we're 0.005, so that's great. From there, let's go over and check out the ground to the frame of the car itself and see where we're at. So once again, we're still good because we're at 0.0064. Now, I'm gonna go to the alternator and look at the ground here. So I'm gonna go to the housing of the alternator, and we're still well within it. It's 0.03 to 04. So wonderful there. Now let's go to the starter. And I'm looking at the starter, and we're still 0.0344. So we're still well within the bounds of what SAE standards are.
Now you can do this on the positive side, negative side, either one. I mean, this is just a quick reference for you guys. Now, keep in mind the car that we were actually illustrating this on was a pristine car. So we would expect nothing less than having really good connections and all here. But as you get into older vehicles, these are things that you need to look for just to make sure that you are replacing the correct components that are not going to leave the customer stranded or leave a bad taste in their mouth.
You know, Jeff, that's a good point. Try it out on known good vehicles so that you have a point to go by to say, well, you know, I just tried it on one that's good, that doesn't have a problem, and it's a lot better than what the SAE specs illustrated.
Cool. So now we're going to do something a little bit different. We're going to go to our next slide. We're going to have a little pop quiz for everybody on this.
Oh, hey, can I point some of this out real quick?
Yeah, go for it. Then we're going to ask a poll question.
Perfect. So I want to start out here just illustrating voltmeter number one. We're right here at the alternator, and we're looking at 14.6. And then I'm moving over, looking at the voltage drop on the positive side, going to the B plus on the alternator. I'm looking at 0.2 of a volt. And then I'm going from the ground side back over to the alternator body, and I'm looking at 0.10, so 0.10. So I guess our poll question is going to be popped up as to what should the voltage measurement be in voltmeter number 4. So I'm right here on the battery itself. What should my battery voltage be? So our poll here is 14, 13, 14.3, or 15.3.
This is a really smart group, so they probably all know it. But
But
Lou put his answer in the Q&A, so if anybody wants to cheat, thanks, Lou.
Did Lou do that?
Lou.
Hey, well then I expect nothing than 100%.
Well, too late. We don't have that. Let's give our guys a. Lou says my fault. That's all right, Lou. You're welcome to come back next time. Give him a harder question, Gail. I don't know if you can make something up. But
There you go.
yeah. So we got about a third of the folks have answered. Let's see. Anybody else want to take a crack at that? Okay, I think we'll call it. And go ahead and show the results. So most of us figured it out. You want to talk a little bit more about that?
Yeah, so as you're looking, and this kind of falls in on, and a lot of these commercial truck mechanics should know this, but as you look at an alternator, I mean, your voltage that it's going to output is right there. It's right there at the alternator itself. As you travel through all these connectors, you've got voltage drop. So that's where all this comes into play. So as we start out at 14.6 at that alternator itself, by the time we go through all of these other voltage drops, we're going to end up at the battery at that 14.3. Now, in the trucking industry, and we're hoping that a lot more of the manufacturers are going to go this direction, they're looking at putting voltage sense leads at the batteries themselves. And the reason behind that is if you're at the alternator and you're outputting 14.3 or 14.4, by the time it gets to the batteries, it may be down to 13.9. Well, a lot of your AGM products do not like to charge at that low of a voltage because it'll never get them completely charged. So you're paying a premium price for those batteries to be in there and work. And when they're not getting completely charged every time, you're starting out with a deficit every time you go and crank it up and driving. So like I said, a lot of the manufacturers are going this route now to put in the voltage sense leads to where that alternator voltage is actually going to be at the batteries themselves. So if it's, 14.4, that's great. If it's, 14.6, that's even better. So that's kind of what we look for. And as we're looking at these police cars and municipality vehicles that have auxiliary batteries that are running in the trunk versus the batteries that are up front, these are things that we've got to make sure that when we're diagnosing and properly testing, that we are kind of fixing these things to where they're actually going to accommodate the units and the folks that are actually driving them. So that's a big circle around how this all works and how your voltage drops come into play. So make sure you're doing the due diligence.
Cool. We're going to move.
Absolutely. I would say also remember to take this SAE recommended voltage drops pictorial and take a picture of it or take a copy of it and put it in your toolbox there when you open it up, so you'll remember that later on when you come up against a situation of checking these.
But you don't have to take a picture of it because you can fill out our 5-question survey at the end of this.
Dun, 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 dun.
And that will help us make the Pro Clinics better, but also you can request a copy of this presentation or a recording link of it if you have anybody else in your shop that wants to take a listen. And
what do we got here?
just by filling those 5 questions out, not only will you help us, but you'll be entered in a chance to win this autographed mini helmet, NASCAR helmet autographed by Kyle Busch, in your number 18 Joe Gibbs Toyota Interstate Batteries car. So that's exciting.
Absolutely.
And that will pop up automatically as soon as we finish this Q&A section. So Let me kick that off so they can get to the survey. Question number 1, is excessive corrosion on the battery terminals indicative of broken strands in the battery cable?
No, not necessarily. The corrosion is indicative of there being moisture in the air, salt, corrosive electrolysis from the metallurgy, if you will, of the battery having lead. Lead's a good conductor and it will attract that electrolysis, can flow through it and cause corrosion situations. So check your cables separate or on dynamically on the cable or on the battery, but they don't, the bad cable doesn't necessarily affect that.
All right. If you guys have any questions, put those in the Q&A tool. You can find that in your Zoom toolbar down at either the top or bottom of your screen, wherever you have it set. Couple questions around connections. Are butt connectors that you heat seal acceptable? I think the crimp connectors with shrink wrap work good. For wire repairs, I find the Del City solder crimp splicer works best. Anything on connections?
I would say absolutely. Anytime you can seal that, if you have when we talk about butt connectors, we think about the old type that have open on each end and accessibility to the moisture and to the various elements outside. If you seal that and you have a situation that seals it away from the elements, that's much, much better.
I think every time you talk about butt connectors, I just kind of giggle. So
I understand.
Some butt head.
What is the normal range of voltage drop from the alternator output to the battery terminal positive?
We say 0.3 of a volt with the alternator under approximately 75% load, if you will. Turn on the headlamps, you have the engine running, turn on the headlamps, turn on the AC high blower, turn on various accessories that it needs to make that alternator work. So typically if you have a 100 amp alternator and you load it up to 70, 75 amps and you're checking between the B plus of of the alternator and the battery post during that time. And you should never have more than 0.3 of a volt drop on that cable or connection.
All right. If the battery is not fully charged at time of checking alternator voltage, can we assume the voltage will indeed be less than 14.6, especially with newer vehicles and computer controlled
alternators? Yeah. Yes, it can. It can be lower. That's why we really want to make sure the battery's in good shape, once you start doing all these tests. So that's primarily the first thing that everybody does is check the battery, because it's always the battery's fault.
Start with a battery tester like the Interstate Batteries pulse battery
Pulse
tester.
Yes, the
That'd
conductance
be a
tester.
great one.
Yeah. Looks like that's most of what we've got for today. You've been talking about voltage drops in relation to resistance and current pathways between battery positive to battery negative. Can there be a voltage drop associated to the battery that is unable to provide the current demanded of the circuit? For example, internal battery resistance values.
Well, the batteries, if it's really low, it's going to cause a problem, but it won't elaborate on the cable or connection as far as that is concerned. You're isolating that when you take your digital multimeter and you're isolating between the two ends of that cable, that connection that you're making. So you're isolating that. However, if you allow that battery to become very discharged, obviously it's going to cause a no start, or could cause a no start condition that's not associated with that. You need to, as Jeff was just talking about, that's one of the fundamentals you need to start with, is the visual inspection, and then check your battery. It's the heart of the electrical system, and so check it first.
Yep.
All right. Last question, Gail, are you single and available?
Well, I have been married 54.5 years to the same woman, and that's when you say God bless. But anyway, happily married. So
Okay. All right. Well, that's all we have for today, guys. Appreciate you taking us through all of this. Thank you, everybody who joined us. As soon as we conclude the webinar here, you'll see a pop-up screen on your computer that'll ask you those 5 questions. If you fill those out, we'd really appreciate it. It won't take a minute. Thanks, everybody, and have a great day.
Thank you all.
Thank y'all.